Hello, our objective today is to solve graphically an equation in the form f of x equal k, where k is a real number, then to solve graphically an inequality. Given the graphical representation of a function, we have to solve here two equations, f of x equals -1 and f of x equals 0. Both equations are in the form f of x equal to k, where k is a real number. In the first it's -1, in the second it's 0. To solve graphically an equation in the form f of x equal k, we have two options. Either we read the abscissas of the points on the curve having the ordinate k. So we have to choose here the points on the curve having the ordinate -1 for the first case. This is -1. And the abscissa of the point is 0, so x is 0. Or we can say we want to plot the line y equal -1, which is here. This is the line y equal -1. And we read the abscissas of the point of intersection between the line and the curve. Remember that y equal -1 is a line parallel to the x-axis. So we plot the line y equal k, which is a line parallel to the x-axis, and we read the abscissas of the point of intersection between the curve and the line. In the first case, it's 0. X is 0 is the solution. In the second case, f of x equals 0. Either we read the abscissas of the points on the curve having the ordinate 0. So we have 2 points on the curve having the ordinate 0. This is the first point, and this is the second point, and we have to read their abscissas. The first one is -0.4, the second one is approximately 2.4. So, or we have to plot the line y equals 0, which is nothing but the x-axis. This is the line y equals 0. It's the equation of the x-axis. And we read the abscissas of the point of intersection between the curve and this line. We have the same answer, and this is the solution of the second equation. Now we move to solving an inequality. The inequality is f of x strictly larger than -1. So we have to read the abscissas of the points on the curve f having the ordinate strictly larger than -1. These are all the points on the curve having the abscissas larger than -1, without this number for sure. And here also all the points on the curve having the abscissas larger than -1. We can also say we plot the line y equal -1. This is the line y equal -1. And we read the abscissas of the points on the curve that are strictly above this line. So this is the line D, y equal -1. We read the points on the curve that are above the line and not on the line. So these are all the points, they are in yellow, and we have to read their abscissas. The abscissas is from -1 till 0, open at 0, and then from 1 to the right, it means open at 1, till plus infinity. So this is the solution of the inequality. Now we want to solve the inequality f of x less than or equal to 0. It is to read the points, the abscissas of the points on the curve having the ordinate negative or equal to 0. These are all the points on the curve having the ordinate negative. Also here we have points on the curve having the ordinate negative, and this is the point on the curve having the ordinate 0. The same here, this is a point on the curve having the ordinate 0, and all these points have the ordinate negative. So the solution of this inequality is the abscissas is formed by the abscissas of these points. Or, so here we have to read the abscissas of the points on the curve having the ordinate less than or equal to 0. Or we can plot the line y equals 0, which is nothing but the x-axis, as we said before. And we have to read all the abscissas of all the points on the curve that are on the x-axis or below the x-axis. As we see, these are the points of the curve that are on the x-axis or below the x-axis. To read their abscissas, it's from minus infinity till minus 1, union from negative 0.4 till 1, we open at 1, then we have from 2.4 till plus infinity. So this is the solution of the inequality from minus infinity till negative 1, from negative 0.4 included because it's a point on the x-axis, till 1, we open at 1 because at 1 we don't have an image. Then from 2.4 included because also it is a point on the x-axis till plus infinity. Thank you.